recording this. There we go. The homework I assigned, blah, blah, blah. There we go. Flip the page. Let's take a look at the next stuff. Question number 1. Units are important. If I multiply centimeters and centimeters, I get centimeters squared. Meters squared divided by meters, the squareds cancel. One of the meters cancels with the meter on the bottom. So 4 meters, 17 meters. Question 3, the answers are right here. Question 5 through 10, the answers are down here. 12 is up here. Comments, questions, concerns on any of those? Going once, twice. Sorry? Are there any questions? Okay, so we're good with all this? Well, if you were good with this, that means the quiz should have gone, at least the last question on the quiz should have gone well. I haven't gotten to the last question on the quiz yet. So actually the last bunch of questions, the one where you're isolating for formulas and the one where you're applying formulas, that whole section should be good. Your bird died? Oh, your brain cells died. Well, it's just a quiz, so you have an opportunity to do corrections when I hand it back so you can improve for the test, which is coming. Here we go. Today, test? Of course. Why wouldn't you want to do that? When the book is done. Here we go. So, ladies and or whoever you are, gentlemen, and everybody else. Yes, this should be grade 8. Okay? What I would like you to do real quick here, I'm going to give you some time to do it with the person sitting beside you. I'm going to give you till the big hand reaches the 10, which is 12 minutes, which is more time than you need. If you are not sitting beside someone, I want you to move so that you're close-ish to someone. I do not want you to do this in isolation, even if you slide over, so that you're discussing this with people around you. I want you to fill in this chart. If the English says this, the math says what? Go. But you're working together. Discuss it. Whoever's Sunny D container that's going to make it to another set. Okay, that's time. How far are we? Hands up if you're done. Hands up if you're halfway. Hands up if you're over halfway. Hands up if you're under halfway. Okay, keep going. Yes, product means multiply. Stressed as well. Where did that come from? That's what I want to know. Hey, are we done?
Oh no, we're not done.
The stretch distance, that's what I have KS. Where does this come from? Presley's done? Oh, and moving on. Okay. That I don't understand. Okay, so it sounds like we're done. So let's keep going. Here, flip. Go. Let's go to take a look at the top. Go to the top. Sorry, rather. Let's see how we did. So let's rattle these off. Gentleman at the back, stop talking, please. No, if it's not his, don't put it on his shoulders. Why? Why are we doing things? Whose is that? Put it in your bag. Middle school ended like a semester and a half ago. Put your stuff away. 5 more than a number. What does it mean? What does it mean to be more than something mathematically? You're adding. So what are you going to do? X plus 5. Thank you. Okay, a number we do not know, and we're adding 5 to it. Nope. You could use M, N, P, Q. A is also a good one. Don't knock A. Okay, next one. A number increased by 8. A plus 8. Love it. 9 less than a number. We are 9 less than something. I love it. X minus 9. 3 times a number. 3A. 3 more than a number. 3 plus X. A 1/7 of a number. You could do it 2 different ways. One is X over 7 or 1 over 7 times X. 5 more than 4 times a number. 5 more than 4 times a number. So how do I do that? You said 5 plus 4x plus 5 or 5 plus 4x. Either is good. The product of 2 more than a number and 6. Absolutely. No, absolutely. Why? Why do you have to? Why like this?
It just is. There's a comma between number and signifying that like the product of 2 more than a number is like one thing, and then
So 2 more than a number is here.
Because if you didn't have the brackets, you'd have to do it like bed math. You'd have to do 2 times 6 before doing next.
Right. We want to make sure we multiply the entire first number. That is some number plus 2 and 6. I love it. How about the product of 3 more than 4 times a number? Sorry, no. How about the product of 3 more than a number and 4? That's going to be the same thing. X plus 3 or 3 plus x and then the 4. Love it. How about the product of 4 and a number plus 5? Cool. How about 1/4 of the sum of a number and 3? How else could we have written this? X plus 3 over 4. Absolutely. Oh, that's a 4, not an x. We could have written it like that as well. Love it. When you've got it in the numerator, you don't have to write the brackets around it because it's understood that there should be a set of brackets there. The sum of 1/4 of a number and 3. Or x over 4 plus 3. We understand how this one and this one are different, yes? Okay. 2 less than 8 times a number. 8x take away 2. Love it. If any of these you're like, no, I don't understand how they got that, please ask. Where am I? We're right here. Yeah, you do. The product of a number and 8. Love it. The product of 2 less than a number and 8. How do I write that? Thank you. The ages of 2 brothers if one brother is 12 years older. 1 is 12 years older. I want the ages of 2 brothers if one brother is 12 years older than the other one. I'm not asking you to add them. I just want to know what they are. Rebecca. Sorry? No, not necessarily.
Isn't it x plus 12 equals x?
Do we have to make them? Do I have to relate them to each other like that? Are they equal to each other? One brother. If you call one brother x, then the other brother is going to be x plus 12. And that's it. I didn't ask you to do anything with those ages. I asked, just give me 2 ages.
Well, it's basically right. I just added another x.
Well, which means it's not. Yeah. Basically right is technically wrong. So I didn't ask you to do anything. I just wanted 2 ages. One age is x. The other one is 12 more, so x and x plus 12. 2 numbers where one number is 1/5 of the other is going to be similar. 1/5 x and just x. Sure. The ages of Angelo and Mary, whose total age is 21. So you've got x plus y equals 21. Even better than x and y, what variables could we have used here? Now all of a sudden, we could have used a and m. Angelo's age plus Mary's age is equal to 21. That's cool. What's another way I could have written this? If I know Angelo's age is A, what's Mary's age? If using that same variable, yeah. Yes, it'll be 21 minus A. So now I've gotten Angelo and Mary's ages using only one variable. I like it. This one here, if you're not comfortable with, you're going to want to get there. Because we got a lot of stuff coming up where this kind of formulation is going to be very, very useful. Writing it like this actually makes it a lot more complicated. The lengths of the jumps if Jill's jump was 15 centimeters longer than Joe's jump. What was the column? One jump is X. Who's X? Jack or Jill?
I mean, Joe.
I said Jack. It's actually Joe. So if Joe is X,
And then Jill is 15.
Jill is going, not 15. Jill's will be X plus 15. Cool. 2 numbers with a product of 28. X, Y, or X times Y equals 28. Cool. Yes.
Any way that like you can, what's it called? Like in these words, is there a possibility that there could be square roots added into it?
Not without saying what. I think it would be things like a number multiplied. What number when multiplied by? I don't know. There's a few ways you could do it, but it would be pretty convoluted. Two numbers that add to 14. Okay. Two numbers that differ by 10. You could write it like that. Could you also, how would we write it here? Like this, like an equation. Rebecca? No. Well, yes. That's one way to do it, right? Is it one way to do it? Yeah, that's what. They differ by 10. I didn't say how. It's true. So there's a few ways. Yeah. So you said y minus 10 equals x. I like that. That works. The number of grams in k kilograms. Now we're using prior knowledge that you should have. So the number of grams you said was x or kilograms? K. Well, use G and K. Let's use G for grams and K for kilograms. So the kilograms equals the number of grams you have divided by 1,000. Or grams equals 1,000 times K. That is true. The value in dollars of X $2 bills. So, and I would maybe not, I'm going to put V there instead for Y. So we're going to start using variables that relate to the meaning of what we're looking for here. The number of hours in M minutes. How do you relate hours and minutes to each other? Rebecca, I see that hand. 60 what? M divided by 60 equals H. That is true. You take the number of minutes you have, you divide by 60, because there's 60 hours in a minute. Other way around, 60 minutes in an hour. You're good. The distance in meters of C centimeters. Oh, sorry, yes? It's not wrong. It's not. Let's think about it. How many hours is 60 minutes? It's 1. So if I put 60 in for M, if I have 60 divided by 60, is that going to give me 1 hour? Or let's do 2 hours. 120 minutes is how many hours? Because 120 divided by 60 is 2. So the formulation given to us by Rebecca is, in fact, correct. Then you can always check it. Do it with values you know. You know 60 minutes is 1 hour, so you plug that in, it should work. If you ended up with 60 times 60, that's 3,600. That's a problem. The distance in meters of C centimeters. Olivia, what are you doing? The distance in meters of C centimeters. Anybody? Did we get this far? I was assuming we were done because we were just talking so much. Maybe we were getting bored. Carolyn. M equals C divided by 100. Love it. I need you to push through, even if you're getting bored, because you actually need to know how to do this stuff. Two numbers with a product of 76, but it is also the last block of a week, so I understand why we're getting lancy. Rebecca. ZY equals 76. I don't love Z, but we can use Z. 3 consecutive integers. Rebecca. No, I want an expression where I could give any three consecutive integers.
So -1, -2, -3.
No, those are the very specific set. I want an expression that would encompass all of them. Tie.
X and then x plus 1 and then x plus 2.
Assuming x is an integer, if I go up 1, I get the next integer. If I go up 2 from x, I get the next integer. Sweet. Is there another way I could have written this? I could have done -1 and -2. I could have done x minus 1, and I could have done x minus 2. Is there another way I could have written that one?
X plus 2, x plus 3, x plus 4.
Yes, but I want to start with x.
Okay.
I want x to be one of the three numbers. You're right, I could have done that, and that would give me a further set. I want x to be one of the three numbers. No, definitely not.
No, if you multiply it, you get
Here, x was the lowest number. Here, x is the biggest number. How do I get x to be the middle number?
x minus 1, and then x plus 1.
There you go. Assuming I want x to actually be one of those three values, these are the three ways you can do it. Cool. How about if I wanted three consecutive odd integers? Harwin. -x plus 1. So then I shove a 2 in there. Gives me -2 plus 1 is -1, which is technically odd. But then you said -x plus, but then you said -x plus 2. Well, which makes it 0, which is not odd. How do I, so here's an interesting question. Maybe you did this in grade 8, maybe you didn't. How do I guarantee a number is odd? Is that easy to do? How can I guarantee? Add it by 5? Well, 3 plus 3 is going to give me an even number, but 4 plus 3 is going to give me an odd number. So I'll just do it. I also need some space here. How do I guarantee odd? Can I mathematically guarantee oddness? Like, can I? Well, obviously I'm asking you the question. I can. But is that the easier? You've got odd and then you've got even. Is there a single operation you can do to guarantee oddness? An even plus an odd? Yeah, but what if I start with an odd number? Then an odd plus an odd is even. No, you have to start from any number. It is not possible with a single operation to guarantee oddness. It's just not. I can prove that to you later if you'd like. But is there a single operation that I could do to guarantee evenness? If you think there is. What is it? What? No, I'm not guaranteeing evenness. I'm guaranteeing 0. I want to guarantee evenness. Times 2. Yes. If well, Jay didn't say it loud enough. If Hamrid said it first. If I take any given number x and I multiply it by 2, I am guaranteed to have an even number.
Yeah, because they're both positive.
Positivity has nothing to do with it. It's odd and evenness. Doubling a number doesn't matter what it is. Any odd number, you double it. You know, like 3 times 2, 6. 5 times 2, 7 times 2, 9 times 2. I could prove it to you for all numbers everywhere, but do you get what I'm getting at? So you can take any number, and by doubling it, make it even. And then how do I take an even number and guarantee oddness, Carolyn? I could add or subtract 1. That is how you can come up with 3 consecutive odd integers. In this case, it's not possible to include x in the list, but we still guarantee ourselves 3 odd numbers. Okay, next one. Jessica is now twice as old as Joseph was 9 years ago. Yes. J-O for Joseph. Okay, what am I going to do with J-O?
-9 equals J-E for Jessica times
J-O minus 9 equals almost. If because I want twice as old, but she, J-E, is twice as old as something else. So you have to multiply the something else by 2. She's twice as old as Joseph was 9 years ago. So it's this side that we have to multiply by 2. We take Joseph's age, we go back 9 years, and then we double it. And that's what's going to give us Jessica's age. We are multiplying by 2 on the wrong side.
So I could also divide Jessica.
Yeah, you could have JO minus 9 equals JE over 2. Yes. Because half of Jessica's age would be Joseph's age 9 years ago. I heard up at the front, you guys said this was the one you're stuck on? Makes sense? Okay. 5 times one number is 7 more than 8 times another. Rebecca. 5m equals, say that again.
7 plus 8.
Cool, love it. Anita's age doubled is 5 years less than Lisa's age tripled. Anita's age doubled is 5 years less than Lisa's age tripled. Rebecca, I see that hand again. 2a, so doubling Anita's age is a fancy word for equals. 5 less than Lisa's age tripled. So how do you finish that off, Rebecca? Triple Lisa's age minus 5. I love it. And then the last one, this is easy. 3 less than 4 times a number. That's just going to be 4x minus 3. So this was just an exercise in getting you guys to, well, first of all, some of us seeing where we're at, some of us, lots of us, surprising number of us, forgot that product meant multiplication. That's totally cool. Yes. Okay, guys, stop talking. There's a question.
So the 5 times one number is 7 more than 8 times another.
Yep.
I would say 5x plus 7 is 8y.
Because the 7 more is on the other side of the is equals. If 5 times one number is something, that means 5 times that number equals something. And so everything that comes after the is going to be attached to the second expression. If you added 7 on this side, that would say that 5 times one number plus 7 is 8 times another number. Because of the language and the order that the English is in, the 7 more has to come after the equal sign. Because of this word right here. And math is picky with its language. Sometimes. In this one, it's is. Yes. Hey, she wasn't here when I said that. Give her a break. Let's take a look. Tuesday was the 12th? Yeah, you're right there. It is. Look at that right there. My bad. I'm sorry. Totally unrelated to that. I will get that video up. Do I dare? Let's finish the lesson, shall we? Yeah, and you guys have a whole weekend to do all the things I'm going to assign. Okay, so flip the page. Here we go. Buckle up. I don't care how much time's left. Buckle up. So we need you to stop talking, otherwise I'm going to give you more homework. Important translation. Times is. Multiply is. More than means. Less than means. Twice means. 2 times something. Decreased by is. Yes, subtraction. Increased by. Sum is also addition. Fewer means. Which means. Difference means. A product is. And a quotient is. Cool. So now I'm just going to start. We're going to start the party here. We're going to take us through what it looks like to start solving some of these problems. Okay, here we go. There it is. So, we're going to do basically the next couple days, and we're just going to do a whole bunch of these things, and then I'm going to give you a bunch of time to practice these things. But it's just getting you guys into the habit of interpreting the English and turning it into usable mathematics. So the first example is this. The second of two numbers is 6 times the first. Their sum is 77. We want to find the numbers. So if possible, draw a picture or a chart. It's not, so let's move on. How can I begin to establish what's going on here? I need variables. If I can do it with one variable, so much the better. Let's throw down a variable, Carolyn. I want to do it with one, if at all possible. So I'm going to put a star here. I'm going to say that. Use one variable. If possible. I will show you how using multiple variables ends up looking, but it involves techniques that I don't really want to force you all to learn. So if you can do everything I'm going to give you can be done with a single variable. So let's try it. One variable. What are we going to assign that variable to? X is going to be what? One of the two numbers. Okay, cool. So hold on. Our first number, I hear too much talking. Our first number is going to be x. The other one's going to be 6x. Yeah, because we have a relationship here. Because the second of two numbers is 6 times the first. That tells us that the second number is going to be 6x. How are those two numbers related to each other? Together they're equal to 77. Together mathematically means I'm doing what? I'm adding them, yeah. So we're going to get x plus 6x equals 77. Well, now that's easy to solve. What do I do first? I group my like terms, yeah. Simplify. 7x equals 77. Are we done? If x equals 11, am I done? Nope. No, x does not equal 77. X equals 11. I want to find the numbers plural. Have I found both numbers? Now I have to go back and I have to plug in what I just found. So now I want, 6 times 11 is 66. So what are our two numbers? 11 and 66. And we'll finish this stuff tomorrow. Days we don't have school don't count. Yes, I know. Tuesday, you're right. I will not see you tomorrow. I will see y'all on Tuesday. Have a great day. Pack up and get out.